Hello, students. Welcome back to another Friday edition of Stats with Mats. We're going to do a homework review today, specifically that of mini homework 5. Okay, so let's get into this in the interest of keeping this short, keeping this efficient, and getting you to the end as rapidly as possible. I asked you here to perform a regression analysis, and specifically that required you to use the data given to you, of which there were 11 pairs, to calculate the value for B, the slope coefficient, and then use that to estimate A, the value of the y-intercept. So getting into the problem, is there a relationship between time spent studying for an exam and the score that students get on that exam? So I am wording this problem in such a way where X is clearly going to be time studying for the exam. Put another way, X, my independent variable, is how much time you put studying into the exam. And I'm hypothesizing that that will have an influence on Y, the dependent variable or the variable that is being affected. In the case of this question, it's what score you actually got on that exam, perhaps an exam in this class. So Y is the student's grade, and X is the number of hours that a student put into this. Both of these are interval level measurements. They are on a clearly defined scale. They have a clearly defined measurement strategy, and the distance between points on the scale is constant, right? The difference from 1 hour to 2 hours is the same as the difference from 2 hours to 3 hours, and so on and so forth. So I asked you to use this data and to calculate both the regression coefficient, that is the average effect of a 1 hour increase in time studied on a student's exam score, and to figure out what would be the expected value of Y, the test score, assuming a 0 on the actual exam, or assuming a 0 on time spent studying for the exam. So getting into the table, you were given values of X and Y, and you needed to use those values of X and Y to then calculate everything else you needed for the equation. Now, the equation for B and the equation for A requires you to have N, which is going to be 11 here. It requires you to have the summation of X, the summation of Y, the summation of XY, which was obtained simply by multiplying X by its associated Y. So 6 times 82 for the first pair, 10 times 88 for the second pair, and so on. And finally, you had to calculate the summation of X squared. So that's each individual X squared and then finally summed. So here's what I came up with. The summation of X I calculated to be 52. The summation of Y is 709. The summation of XY is 3,963, and the summation of X squared is 340. Now, getting into our hypothesis test, let's check out our steps. Step 1, what do I know? I know that X, or my independent variable, is hours studied. And I know that Y, my dependent variable, is the exam score. And I know that I have 11 pairs of data. That will be N within my equation. Now, as far as hypotheses, let's go back and read the question. Is there a relationship between time spent studying for an exam and the score students get on that exam? Now, it's very easy to hypothesize that, okay, clearly we all want to believe that the more time you spend studying, the better you can expect to do on an exam. But the question doesn't ask you for a direction. I want to be very clear about that. Is there a relationship? In a correlation or a regression problem, you can have a significant effect that is positive, and you can have a significant effect that is negative. It can be significant in either the positive or the negative direction. So when you are asked, is there a relationship, you need to assume that there would possibly be a world in which you find hours spent studying for an exam significantly decreases the score that a student gets on that exam. I don't want that to happen to you, obviously, but we have to account for that being a legitimate mathematical possibility. So H0, there is no effective hours studied on test scores. That's the only situation in which you could not find a significant effect. H1, there is an effective hours studied on test scores. And it's implied there by saying there is an effect that could be positive or it could be negative. Steps 3 and 4 don't have to show, but I want you to have it in your head for the purposes of interpretation when you have p-values, right? If you think about Wednesday's video and you think about looking at the p-value to establish whether you have to interpret it as a significant coefficient or not, let's just assume we would set it at 0.05, okay? And that would be the critical alpha level that we would use to get a critical value of B to compare each coefficient to. So, step 5. I want to first calculate B because I need B in order to get a value for X, or for A, pardon me. I need B, I need the regression coefficient in order to get A, or my y-intercept. So, going through the equation, 11, which is N times 3,963, that's the summation of X, Y, minus 52 divided by, times, pardon me, 52 times 709. That is 52, the summation of X, times 709, the summation of Y. That is the numerator of my formula here. And I will divide that numerator by the associated denominator. 11, again, that's N, times 340, that's the summation of X squared, minus 52 squared. That's the summation of X, which is then squared. That will reduce to 43,593 minus 36,868 divided by 3,740 minus 2,704. That will further reduce to 6,725 divided by 1,036. And my value for B, 6.491. Now I need to interpret that, but I'm going to save that for the end because my math work is not actually done here. I need to use that B in order to calculate the value of A, or the y-intercept. So A is going to be expressed as 709 minus 6.491 times 52 over 11. What are the components that we're dealing with there? Well, 709, you will remember, let's go up to our table, should be this the summation of Y. And that is then, I'm using that to start, 709 minus the value of the B coefficient, 6.491, times the summation of X, which is 52, divided by N, which is 11. So that will reduce, if I scroll down here, to 709 minus 337.532 divided by 11, which is 371.468 over 11, which is 33.77. So recapping what we've done here. B, or my slope coefficient, is 6.491. And A, or my y-intercept, is 33.77. So, the most important thing, how do we interpret this? A 1 unit increase in hours studied is associated with a 6.491 point increase in a student's exam score. How do I know it's an increase? Because that is a positive coefficient. Should it be negative, I would be dealing with a decrease. But in this case, it's positive, which implies it has to be an increase, right? An increase in X leads to an increase in Y. Then finally, when hours studied equals 0, the exam score on average is 33.77. Why did I say on average there? Because if I go up here, you can see that I actually have a data point here. When X equals 0 in the observed data, I actually have a value for Y of 23. That's one data point. What you are getting, the y-intercept, is the average value of Y, assuming X equals 0. And that's why those numbers don't match up. Either way, a 1 unit increase in hours studied is associated with a 6.491 point increase in student exam scores. When hours studied equals 0, the exam score is 33.77. So I can also conclude, don't spend 0 hours studying for your final exams. Spend more. Each hour, a 6.491 increase. No, not for you personally, but let's hope that we all put our time in. Now, the last thing I want to show you is you got familiar with looking at, on Wednesday, you got familiar with looking at Stata output and getting my values for A, B, the y-intercept, and the p-value. Let's just go through this. What you're seeing here is a regression of x on y, where all I did was I went into the data editor in Stata and I inputted these 11 pairs of data across the two variables of x and y. And then I ran a simple regression using the incredibly complicated command of reg-yx, where the dependent variable goes first and the independent variable goes second. So what did we say was our coefficient, our value of b? Did we say perhaps that it is 6.491? That's exactly what Stata has shown me here. So I know I got the right answer. Is that significant? I didn't ask you to do that by hand, but you can see here, yes, it is a very significant finding. The p-value associated with this is less than 0.001. So I could say with 99.9% confidence that there is a significant and positive relationship between hours spent studying for an exam and a student's score on the exam. My constant, or my y-intercept, does the term 33.77 mean anything to you? It should, because that's exactly what I'm seeing here, 33.76834. We just rounded that off to 33.77. And you will remember the final thing I wanted you to be aware of was the R squared. It's very high. In a very simple bivariate formula here, hours studied explains 84.53% of all variation in student test scores on this exam. So that's a pretty powerful relationship between these two variables. All right. So that is bivariate regression by hand. Not too terrible. I have been very, very pleased with this, how students are doing on the homeworks. Keep it up. Keep working hard, and you can count on me to help you if and when you need it, however much you end up needing that help. Okay. Have a great weekend. Let's go Buckeyes. And I'll see you on Monday. We're coming to the end of it now. Stay safe and take care of yourselves.